All right, go ahead and begin the warm-up, pause the video, and come back in 5 minutes. All right, so to check our answer on the warm-up, remember we're going to be factoring quadratic expressions where the a value is not a 1 anymore. So we got to remember a few extra steps. We're going to start the x. Remember, that's going to be a times c, and then your b value. This is a, this is b, and this is c. So we're going to start by multiplying a times c, which is negative 20 times 3, which is negative 60. All right. And then we're going to drop our b value, which is 11. So now we are asking ourselves, is there anything that multiplies to negative 60 and adds up to 11? So let's take a quick minute. Again, you can start by creating your list of numbers. So if we have 60, we can divide it by 1, 2, 3, 4, 5. So 60 divided by 1 is 60. 60 divided by 2 is 30. 60 divided by 3 is 20. Remember, I need to get to 11. And then 60 divided by 4 is 15. And I think I might have it with 4 and 15. So let's go ahead and check this. We can put a 4 and 15. Okay. Now, one of them has to be a negative because it needs to multiply to negative 60 and it needs to add up to positive 11. So in this case, we're going to make the 4 a negative. So negative 4 times 15 gives you negative 60, and negative 4 plus 15 gives you 11. So that's good. Remember, the next step is to divide by whatever the a value is. In this case, we're going to divide both of them by 3. All right. So let's go ahead and put them into factors. Okay. Now, negative 4 over 3 is not going to simplify, so we're just going to go ahead and bring down the fraction. 15 divided by 3 does simplify to 5, so we're just going to go ahead and bring down the 5. And remember, if you ever end up with a fraction on one of the factors, we're simply just going to move that fraction into the front. So now the answer is going to be 3x minus 4 times x plus 5. And that's the answer. All right. So now what we're going to do is go ahead and open your notes. And we should be on 7.7 factoring special cases. So today I'm going to show you 2 special cases that you have seen before because we used them when we were multiplying. The first one that I'm going to introduce you to is the perfect square trinomial. So we're actually just going to approach this as any other factoring stuff, any other factoring expressions. There is a pattern that you can follow. I'm not going to show you guys the pattern. We're just going to continue to do the exact same thing. Okay. However, the answer might look a little different if you notice the pattern right there. So example number 1, we're going to approach it the exact same way. We know that that's a 1. So I'm going to create my x, a times c, and my b value. So I'm going to multiply 1 times 49. Remember, this is your a, b, c. And I get 49. My b value is 14. So now I'm looking for 2 numbers that multiply to 49 and add up to 14. And in that case, that would be 7 and 7. Don't forget, we still got to divide by our a value. So we're going to divide them by 1. Now, when we put them into factors, you're going to notice one thing. So we got 7 divided by 7, which is 7 divided by 1, which is 7. And we got another 7 divided by 1, which is also 7. So if you notice, those 2 factors are the exact same. So we call this a perfect square trinomial because we have the same answer on both, and we can actually rewrite this as one single factor. All right. And again, we call that a perfect square. Now go ahead and turn the page over. Now we're going to do difference of two squares, which again, it follows a pattern, and you might remember this from multiplying polynomials. But let's just say I'm doing question number 1. Okay. So question number 1, if you notice, there's something missing because we have 8x squared plus bx plus c. So in this case, we actually have our a value and we have our c value, which means b value is missing. So what does that mean? That means that b is equal to 0. So let's go ahead and still create the same x. So a times c, and then your b value. So let's go ahead and do that. We know that this is a, and we know that this is b. So 1 times -9 gives you -9. And remember, we already know that b is equal to 0. So b is going to be 0. So now I'm looking for two numbers that multiply to -9 and add up to 0, which in this case is going to be 3 and -3. All right, 3 times -3 gives you -9, and 3 plus -3 gives you 0. Now don't forget, we still got to divide by our a value, which in this case is going to be just 1. Okay. So our factors are going to be 3 divided by 1, which is +3. And then -3 divided by 1, which is -3. And if you notice, oops, they are the exact same thing, besides one of them has a positive and the other one has a negative, which is why we call this a difference. All right. Now, there is an extra problem that I want to go over. So, for example, if we look at 2, same thing. We got 8x squared plus bx plus c. We can clearly see that this is our c value, and we can clearly see that this is our a value, which means b is equal to 0. So, same concept. I'm going to multiply my a times my c value, which in this case is going to be 4 times -9, which is -36. And we already know that my b value is 0. So I am looking for two numbers that multiply to -36 and add up to 0, which in this case is 6 and -6. However, if you notice, this problem actually has an a value of 4. So we need to divide both of those factors by 4. Hopefully you remember your calculator steps. Okay, so if you simplify this on the calculator, remember that we're going to be using 6 A, B, C, 4, and then a second A, B, C. And you should be getting 6 divided by 4, which is just 3/2, positive. And then -6 divided by 4, which is -3/2. And because we ended up with fractions, what we're going to do is we're going to take those denominators and put them in the front. So now my answer is going to be 2x plus 3, and then 2x minus 3. And there it is. So remember, we're gonna have special cases now, perfect square trinomials and difference of two squares.